Hi, this is Mr. Manley. Here I'm going to take a look at rational algebraic expressions. The big key here is that the basic principle we were looking at is that in a rational expression, a times b over a, I can cancel the a's because a over a is 1. And it has to be a factor, because a times b over a, I can split that up into a over a times b. And then you see there I've got a is 1. And then 1 times b is b. Okay? Not to be confused with a plus b over a. I can't cancel that. What would I get? Would that be b, or would it be 1 plus b? How would I have to split this up? If I have a plus b over a, that's a over a plus b over a. Because that's how addition of fractions works. You see, adding them is different than multiplying them. They don't work the same. So we certainly can't cancel. Take a look at that. That's a common error that students continue to make. Try not to be one of those students. Okay. So what I think you want to pick up there is that factor, then cancel. Factor, then cancel. You have to have factors in order to cancel within a fraction. Looking at what I have here on the screen, there's nothing to cancel because I don't have factors. Okay, these are not factors. I got a couple of terms. Let's look at factoring them. Whenever we're factoring, the first thing, we're factoring a polynomial, the first thing we're always looking at is there a greatest common factor? Looking at this, 8x squared plus 16x, is there a greatest common factor? Yes, they have an 8 in common. And they also have an x in common. Factoring out an 8x, I'm left with x plus 2 over 4x. Now I've got factors. Factor, 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 factor. Are there any factors in common where I can cancel? Yes. I can do a 4 with a 4 here, leaving a 2. I can cancel that x with that x. And that leaves me with 2x plus 2. What are the instructions? If the instructions, instructions probably say simplify. Being factored is not being simplified, actually, because what does PEMDAS say? PEMDAS says do multiplication. So really, if it says simplify, I should multiply that out. There. Let's move on to the next one. Again, no factors. No factors, no canceling. Can I factor this? Numerator, do you recognize, I hope, the difference of squares? Denominator, I'm looking at FOIL. An x. And then what can I do with the 12? I could do, what if I tried plus 2 plus 6? And then I would have 6x plus 2 is 8x, but I need 7x. So 6 and 2 don't work. How about 4 and 3? That's 3 plus 4 is 7. So that's factored correctly. Anything, now I've got factors. 1 factor, 2 factor, 3 factor, 4 factor. Those are all factors now. And I can cancel. X plus 4, leaving x minus 4 over x plus 3. Great. One more. Same thing we're considering here. We just got this tricky little notation or how this is set up. We don't have the fraction. It's not set up as a fraction, but it's hidden here, right? Because that -1 is telling me to do the reciprocal of the factor that it's applying to. -1 is applying to the factor 9x squared minus 4, which means that this is equivalent to 2 minus x minus 3x squared over 9x squared minus 4. No factors, just that and that. So I've got a factor. Let's see. I'm going to rearrange the numerator. -3x squared minus x plus 2 over 9x squared minus 4. Okay. Let's look at factoring the numerator. I might, before I do the trinomial factoring, I might factor out the negative. 3x squared plus x minus 2. Hopefully you know how to do that, right? Factoring out a negative, and then you do the opposite on all the signs. Now let's look at factoring the trinomial. I'm going to have a 3x and an x in order to get a 3x squared. And I'm going to have to use a 1 and a 2. Well, I see where to put them, a 1 there and a 2 there. And I need the outside and inside to come out positive. So if I've got 3 on the outside and I've got 2 on the inside, what do I need? I need the outside to be positive, right? So that would be positive 3 minus 2. And that gets me the 1 that I need. So I've got 3x minus 2x is 1x, which is what I needed. All right, that's the numerator. The denominator, perhaps you can see, is a difference of squares. 3x plus 2, 3x minus 2. Factors. Factor, 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 factor. Cancel. 3x minus 2, 3x minus 2. Simplified as much as possible. I could go like this. Negative x minus 1 over 3x plus 2. Okay, so that is rational algebraic expressions. And what's the big idea? In order to work with these rational algebraic expressions, you need to factor. Then, if you've got common factors, you can cancel them. What does canceling mean? In this case, it essentially means you're multiplying by 1. A over A cancels, and that becomes 1. And then I'm multiplying that by whatever.